By the end of this video, we will have a CRUD REST API written in PHP, and we will use different technologies. As you can see here on the screen, I have a small schema. We have Laravel as a PHP framework. We have the composer. We have Docker here, and we'll use Docker-compose to link these two services. This is the PHP app that we will write from scratch, and this is the Postgres container. We will run our database in a Postgres container. We will implement five functionalities to have 4 operations: create, read, update, and delete. Read will be 2 functions. That's the reason why we are 5. And then we will also test this application. We will use Postman, but you can use any tool you want, and Table Plus, and maybe even Docker exec, which are the steps we will go through. The first is to check the prerequisites, then we will create a new Laravel project, then we will code the application, then we will run the Postgres container, we will check it if that works properly, and then we will build and run the service, the Docker image, and then the Docker container. And lastly, we will test the application using Postman and maybe the CLI. Okay? So, which are the prerequisites? The prerequisites are not many, but we need the PHP. I have version 8.2, I think. Let me check here. PHP -- version. Okay. Perfect. Then, of course, you need the composer installed, the Docker installed, so Docker -- version. And optional, you can have VS Code if you want to follow along, but you can use any IDE you want. And lastly, you might need the Laravel CLI. Now, you can create a PHP project in different ways, but to follow along, I recommend to using something called Laravel CLI. You can check if you have it, Laravel -- version. Okay, so I have it already up and running on my machine. And then any tool to test the APIs. So Postman and Table Plus, or any tool you want to test a DB. This is optional. You can also do this directly from the command line. So we can start. So first of all, you should put yourself in any folder you want. I am in this folder called C workspace /live. So to create a new Laravel project, you should type Laravel new, and we will call this Laravel CRUD API. You can call this whatever you want. If you want to follow along, you can use the same exact name. Now, done. So now let's step into the directory. So cd Laravel CRUD API, and then we will open this. For example, we're using Visual Studio Code dot. And we have the VS Code project. Nice. Let me reposition this, and then we are basically ready. Okay, so as you can see, we have some files here, and we have this empty project. So the first thing that I want to do is to see if this service is it's ready. So let's type PHP. We need PHP installed. The PHP CLI artisan serve. Okay, and this is super fast. Let's go here. Okay. And we should have this. Okay. Oh no, it was already up and running. Okay. And we have this Laravel app up and running. Laravel app up and running here. 8,000. Perfect. You can see it. There we go. Okay. Nice. So this does mean that the app is working. Now, let's create the whole application. So to do this, first of all, let's stop this. We don't want this. Let's make it clean. Okay. So to code the application, usually I like to start from the configuration of the database. Where is the configuration and the connection with the DB for this Laravel app? It's here in a .env file. There is from line 11 to 16 something called DB connection. So we need to change this. We need to put PSQL, and then as a host, this is very important, we need to put DB. DB will be the name of the container. We will not use any P, but we'll use the name of a container. This is very important. 5432 as a port, and then here as a database username and password, I'll just use Postgres because it's easier for me to remember. So let's put it here, here, and here. So we are done with the configuration. Okay, the .env file is a bit long, but we really just need to change this one. Now, after this, we need to create some resource, and usually in these examples, I create a resource called users. In this case, I don't want to create a called users because we already have a resource called user. So since I don't want this to clash, can you see here in the models we have this user.php. We will create a resource called player. So we can do this in different ways, but one convenient way is to do PHP artisan make and then model and then player -m. Okay, so check here. If I type this, we will have now a player.php file. Now, I created this model empty, we can say. So I want to add a couple of fields. Okay, let's say that a player should have at least a name and an email. Okay, so add name and email. And by the way, the email will be just a string. Okay, we will not make checks here on the email. So this is the player.php file. Now we need to make some changes because when we created this model, PHP does not create only a model, but it also creates something called migrations. Can you see here in the migrations, we have this last file, can you see, has been created today, 22nd of April, create players table. Okay, a migration is basically an operation to change the schema of the DB. So, and as you can see here, this has been created empty. So here GitHub Copilot is very smart because it recognizes that we need a name and then an email. So we are done with this migration. This will be used after running the application to change the schema of the DB. I'll show this, of course, no worries. Now the hard part, because we need to create a controller. We need to create a file to basically make the operations when we call some APIs. Now, this can be done in different ways, but in the app HTTP controllers folder, this seems a good place to put our player controller. So this will be the controller for the player resource. PHP player controller. Double check. Okay. Nice. So maybe this can also be created with the CLI, but it's okay. So let's create this PHP file. PHP. Perfect. And now, first of all, let's define the namespace for this, which is app HTTP controllers. And then we need to get some reference. We need the models of the player, because this will be the controller for the player. And also we can use this illuminate HTTP request. Now, let's type the class. Every time I create a class, GitHub Copilot stops working. So, no, here it worked. Controller. This extends controller. I don't want to just, I want to know what I'm typing. So here, okay, here we have this class player controller. Okay, so now, first of all, let's display a listen. Display all a listen of the resource. Okay, so we want to list all the players. By the way, we will not return a view, but we want to return a JSON. So return JSON. Let me remove this. By the way, all the code will be available, so no worries. Okay, so here this is to basically get all the players. Now, let's store a newly created resource in the storage. So we need a function called store, and we need this request. Let's also validate this. So let's create like this validate request validate, and we need a name and an email. I don't want to make a check here on the email because basically I will just check if that's a string. Okay, require string. Let's say that we need a string, but we are not checking the type of the email here. Okay, let's stop it here. And now, of course, after validating this, we need to store this. So player create validated data. Let's call it like this. Okay, so this is the data that has been validated, and then after we create the player, for example, we can return the player that we just created. We can also add an HTTP code in the response. In this case, to 201. Then to display this specific resource, so basically this is to get a single user, we can create this function that usually is called show, and we can return this JSON player. This is very, very, very straightforward. I like this, even if I'm not used to PHP, but I still like this syntax. So now to update a user, we need the body, the new body, and we also need the resource to update. Okay, so this function looks cool. Public function update request, and we need the player. We validate the data in the same exact way. We update, and then we return this JSON, but maybe we can return let's say 200. Okay, nice. And now the last controller, which is to remove the specified resource from the storage. I'm not, as I said, super expert with PHP, but I think that I understand the people who really like PHP. Okay, so it seems that we have, so we have the controller. Now, this is not enough. We need to change a file called api.php in the routes folder here. Routes folder, api.php. So we need to add this controller. So for example, we can remove this and we can add this controller. Here GitHub Copilot is correct. So after this, let's leave everything as it is because we already have some example here. So let's get all the players. So there should be 5 routes. Usually here GitHub Copilot is kind of smart. So we need a post to create the player. We need a get to get a single player, a single resource, a put to update the player, and a delete to delete a resource. I just want to check if this is right. Controllers, HTTP controllers here. Index, yes. Nice. So we also updated the api.php file, api.php, this file. Perfect. Now the funny part. So now let's dockerize this application. So let's clear here. So now to dockerize the application, we can create 2 files. So just Dockerfile and docker-compose.yml. You don't have to use the CLI, you can also use the plus button here in VS Code. But as you can see, this created 2 empty files, the Dockerfile and the docker-compose.yml file. Let me go here. So let's start with the Dockerfile. The Dockerfile is a file to create a Docker image. So we want to give the possibility to deploy this application everywhere where Docker is installed. So we can use PHP 8.1 as a version, the base one. Then we can run apt-get update. We want to basically update and also install some dependencies. So apt-get install, and this is it depends on the application that we want to create. So we don't need this, but we want the lib pq, which is basically for Postgres dev, should be for, and then and docker php ext install, and then we have pdo and pdo pgsql. These are basically dependencies that we need to install. Now we can define a working directory, so basically a directory so our application is not in the root folder. Okay, it's not necessary, but usually we do this. And here we have a small typo, php at 1. Okay, php colon. And here now we can run this, which is basically we want to change the owner, -r of www-data, okay, data where HTML storage, okay, storage to per HTML bootstrap cache. Okay, so we want basically to update, this is to update the user permissions. And then lastly, cmd php artisan serve, it's in a very similar way as we did this before. And then we can also define the port. So this one should be the Dockerfile. Let's see if this does work. If we have any issues, I will try to debug this live. Okay, let's just check one moment. This. Okay, nice. Now we need to type and create the Docker compose file. The Docker compose file is a file to have multiple services, and a good example is exactly this one. When we want an application and then, for example, a database. So let's define the services. The services are basically the containers. We can call this service Laravel app. And this can have a container name. We can specify a name. It's not mandatory, but let's do it. So basically the container will be called Laravel app, and then we can define an image, basically. And the image is the name of the image that we want to define. We can use you can use any Docker Hub account you want. Docker Hub is a sort of GitHub for Docker, and we can call this Laravel app 1.0.0. Okay, then if we want to build this project, so we need to define the build. And here you will see this in my tutorials, it's build dot. It does mean build the project using the Dockerfile, which will be in this path. And as you can see, the Dockerfile and the Docker Compose, they are in the same directory. If we will have a Dockerfile in a different directory, we can just specify here basically the path. And then we can specify the ports that we want to expose internally and externally. And then here, if we want to use some environment variables, we can do this in different ways. We can just define the environment variables here, or since here in the PHP project we already have a .env file that already has some environment variables, we might want to just use that file. So we can just do this .env. Okay, and then we want to say that this one depends on another container. Do you remember that in the .env file we specified here the DB host here? Now we are gonna create that service in the Docker Compose file. So here we will have DB, which is the name of the service. DB stands for database, of course. And here is container name. We specify again DB because this is the name of the service, this is the name of the container, which is not exactly the same. Okay, a service can have multiple containers, multiple replicas of the containers. Then here as an image, we want to define not a custom image, but we want to use an existing image. We will use Postgres 12 because I know that this with this image and this version it does work. Then we can specify the ports for this existing image, and then we want to define here the environment variable for the Postgres image. And this is correct, almost correct. We don't need this, Postgres. Okay, so here we are using the Postgres image. This is very important. And then volumes. volumes is a way to have persistency in a container. Okay. Nice. So here we are defining that we want to use this volume. And then we need to create this volume here. Okay? And we call this PG data because I like this syntax. Now, this should be done. Now we just need to test it and fix it if we have some issues. Nice. So first thing first, let's run the Docker container. So we can do this from here. We can do, first of all, let's check if we have any container up and running. Docker ps-a stands for all. So we have all the containers. We don't have it. So we can do docker-compose app. Then we can add -d, which stands for detached. So basically our terminal will still be available after this command. And then the name of the service, db. And this will pull the image from Docker Hub and it will run an instance of Postgres on our machine, also with this cool animation. But the hard part is yet to come. So in the meanwhile, I can create a table plus. I can use table plus because I want to connect with this DB. So we can create another one. Let's create this connection, PostgreSQL. As a host, here we put a local host as a port 5432. No. 5432. As a user, Postgres. And the same as the password and database. So this is the table plus is basically just a tool to test stuff. Okay, connection is okay. And if I click connect, we have an empty DB. You can see here we don't have any table here. This is correct because we just run a Postgres container. Now let's also do this. So here let's check docker ps-a. And here we can try to step inside the Docker container that has Postgres. Okay, so how can you do this? We can do docker exec -it, and then the name of the container, which is db in our case. This is how we named the container db. Docker exec -it. IT stands for interactive and pseudo tty, basically terminal. And then psql, which is a command available for the container, and then -u, which stands for user Postgres. And as you can see here, we are inside the container, and if we type \dt, we don't have any relations. Okay, nice. So let's go back here on the Docker part, and now the hardest part. Let me check 1 second. Okay, now the hardest part. The hard part is to do docker compose build. Okay. To be honest, we really don't need this docker compose build. We could just do docker compose app, but I want to go step by step. Okay, it seems that it worked. So let's check first of all if we have this image, Docker images. Okay, we have many, but as you can see here, we have this one created 8 seconds ago. Okay, this one highlighted. Okay, and now the last step, which is docker compose app. Let's see if this does work. Okay. Port failed. Nice, interesting. Okay. Wait. Maybe there is a mistake in the Docker file. Let's see here. Port 8000. Okay. Let's see. Let's go back. Maybe we have a mistake here. So cmd PHP, I think it's just like this. Let's just type this, but it should be okay. PHP artisan serve. It was serve. Yeah. PHP artisan serve host 0000 and then the port 8000. Okay. I want to change the version of this one. And then we'll try to build this again. Let's see. Let's do a version 1.0.1. Okay, now let's build this again. Docker compose app --build, and then Laravel app. Let's see if we have another mistake. Let's see. Okay, now it worked. Okay, so the CMD file, it had to be changed. Okay, nice. Now, usually when I get this command, the first thing that I try to type is docker ps-a, because I want to check if we have yes, we have the ports here. You see 8,000 here. Nice. Now, how can we check if this is up and running? We can do this in different ways. Maybe we can do docker compose logs. We are in the same folder, docker compose logs. Okay, and we have, it seems that it's working. Now let's clear this. And now I want to do the migration, because we didn't update the schema of the DB. So to do this, I'll show you this in a fancy way. Terminal. Okay, so let's put two things on the side. So, and we want to step in the same directory. So cd workspace. Okay, nice. Let's put like this. Nice. So let's here in the Laravel CRUD API. Let's go to start here. cd live, cd Laravel CRUD API. Okay, so here we will use the DB, and here the other app. So let's do again. Let's see, we have the docker exec. Yes, docker exec -it db psql -u Postgres, and we are inside the Postgres container. If you do \dt, we don't have any relations. Now here we'll do a docker exec here, and we'll execute the migrations directly from the container, which is exciting. Docker exec Laravel app, because we have an app called Laravel. Let me show you. Docker ps-a. We have this app called Laravel app. I don't know if you can actually see it. Maybe not. Here, I don't know if you can see. There is an app called the Laravel app here. So now we can do docker exec Laravel app, so the name of the container, and then PHP artisan migrate. Let's see if this does work. Let me show you this again. We don't have any relations. Okay, nice. This is not pSQL, is pgsql. Okay, nice. Well done, Francesco. So let's change the version 1.0.3. Let's remove the other one. Docker compose down. Let's remove everything. Let's add this again. Docker compose app -ddb. Now docker compose app -build Laravel app. Okay, let's try now. Okay, let's try again. Let's clear here. So let's put one here and another one here. So let's clear. Okay, let's try again. So docker exec -it db psql -u Postgres, and we are inside the DB. Okay, here, and here we can do like this. So here we can type docker exec Laravel app, and then PHP artisan migrate, and now it's done. It was a typo. So now if we do \dt, we see that here we have a bunch of tables. Why do we have 6 tables here? Field, jobs, migrations, passwords, password play. Because Laravel by default it creates some tables. I don't like this approach much, but we still here we see that we have these players. If you're curious, the reason because of this is that because in the database migrations we have different migrations, but we have the players one, the one we created. So now, but if we do select star from players, semicolon, this is empty. We have ID, name, email, created at, updated at. Okay, now let's test this with Postman. Postman here. Nice. So let's test this one. So to test this application, we can hit different endpoints. Let me remove whatever was here. It was another example, of course. Let me remove this. So localhost 8000 API players. Let's try to do a GET request here. Okay, let's here. Nice. And here we see that we have an empty list of players. This is a very good sign that our API are working. Okay. Now let's try to create some players, some users. Okay. So we need a name. We can use AAA and then an email. That, as I said, is just a string. So we can have AAA-mail. Okay, so let's do a post request, and then, so we see that we created a player. And as you can see here, we have 5 fields. We have name, email, updated at, created at, and ID. This is important. This is an auto-incremented ID. Now, let's create a couple of more players, basically users. So this is another player. Let's create a third one, CCC. Okay. Nice. Now let's try to get them all again. So get localhost 8000 API / players here, and we have the 3 players. Nice. This is cool. Now we can get a single player. So if we do go on 8000 / API / players /2, we don't need this. It's confusing. We get the single player here. And if we want to update, for example, this player, we can call this, instead of BBB, Francesco, and as email, subscribe at mail. And we changed the user with ID to. Now, last step, we can delete a player by using just HTTP localhost 8000 / API / players /1. Let's see if we get this one deleted. Okay, we don't get any response, but here in the status we see a 204, which is a very good sign. And now if we try to get all the players again, we have just 2 players. So this was a success. Now, before we close, just let me show you again if we have a consistent status on both the Plus and the Docker exec one from command line. So if we refresh here, as you can see here, we have a list of tables. And if we go on players, we have these 2 players, Francesco and CCC. It's like this. And also, if we go here on the Postgres container, we can just type select star from players, and we see here we have the 2 players. Well done.